Hey, welcome everybody. We have a great presentation today. I'm Ken Dellenbush with Cessna Flyer and Piper Flyer Associations. Today we have Bill Ross, Vice President of Product Support with Superior Air Parts. His conversation will be, watch this before your aircraft's next oil change. It's sponsored by Superior Air Parts and Aircraft Spruce and Specialty. Here's Bill.
Thank you, Kent, and good evening to all. Uh, Thank you very much for attending this evening. Just a quick note about me. My name is Bill Ross. I work in the product support department at Superior Air Parts. I Aviation has kind of been a way of life for me in that I learned to fly when I was 16 years old, and I've been in the business pretty much ever since graduating high school. I've worked in various capacities at companies in engineering and product support, analytical, um, accident investigation. But my real love is product support, and the highlight of my career is to do things like this and talk to fellow aircraft owners about ways that we can increase our safety, the reliability of our product and of our aircraft, and get more bang for your buck, if you will, or get more out of the airplane without shelling out a lot of money. Um, I've worked as a charter pilot, as a flight instructor, corporate pilot, and I'm an A&P and IA. My family has five aircraft at our air park that in which I live at. We have a Cessna 182 and a Piper J3 Cub. We have a Alon Air Coupe, an Aeronica Champ project, and we have a uh, Boeing Stearman. So I do understand what it costs to do an oil change, and I've performed many oil changes throughout my life, both on customers' aircraft and on my own. Um, when we look at aircraft engine oil changes, I like to think of that as a diagnostic, and the title of tonight's presentation is just that, looking at oil changes as a diagnostic. This is a task that you as aircraft owners can perform on your own without the supervision of a A&P mechanic if you're comfortable in doing so. And I think that I hope that you get a lot out of what we're talking about tonight. If you are doing your own oil changes now, maybe you'll look at it in a little different way. Maybe it'll provide some more information to you as we go on. As we talk about tonight, we'll talk about some of the topics of discussion. And one of the first things is, why do we change oil? Why is that such a big deal that we change oil in our aircraft engine? And there are some very, very valid and sound reasons for doing it, both on time, engine time, and also calendar time. And we'll talk about some of those reasons for doing the oil change. Tools required for the aircraft oil change. We'll talk about what we need. You as owners would need to procure if you don't have it, don't have the tools, what you'll need to get in order to perform an oil change and perform it in a manner that is meaningful. And what I mean by that is anybody can go and drain the oil and change the filter. But in an aircraft, we do a little bit more. We investigate and use the oil change as an indicator of internal engine functioning and health. And we'll looking at some of these tools that we'll need to do that properly. We'll talk about how to properly perform an oil change. Some of the techniques and practices will be not matter of opinion, but they'll actually predicated on good sound engineering data. You know, if you've seen any of my presentations before, you know that I am a big and strong advocate for doing the tasks and recommendations set forth by the manufacturer. So all of those, when I talk about how to properly perform an oil change, that will be dictated by your respective engine manufacturer. We'll talk about the examination of the oil and of the filter and what that means and what to look for when we open up an oil filter and we look at the constituents inside as to whether or not we have a problem or we have a healthy engine. It's a very, very good indicator of internal engine functioning and health. And that's what we will learn, hopefully tonight, what we'll learn from the examination, how the engine's actually functioning and if we can safely continue to fly. Also, we as owners, maybe you probably don't do your own annual inspection or 100-hour inspections, but you as owners, if you are doing the oil change, you can communicate maybe more effectively with your mechanic in some of the information that you're learning as you do an oil change, how that information can be beneficial for the mechanic when he's doing your annual and assessing whether your engine is airworthy or not, following the instructions for continued airworthiness set forth by your respective manufacturer. So why do we change the oil? I ask that question a lot, and I hear a lot of people on the street. I've even seen commercials that say, "Oh, you have to change it because the viscosity of the oil breaks down and the oil wears out and things like that, and the oil gets dirty." To a degree, the oil does get dirty. The oil really doesn't lose its lubricating properties at all, or its viscosity. But when we talk about a air-cooled aircraft engine, it is in striking contrast to an automobile engine. The tolerancing in an aircraft engine is such where it will use some oil, it will have some blow-by, much more blow-by the piston rings than we see in our automobiles. These combustion byproducts are very, very corrosive, and that's what we're really trying to do when we do the oil change, is we're carrying out some of those highly corrosive things. The oil doesn't have a lot of dirt in it. If it does, then we have more problems than just oil that has acid in it. You can get some dirt in it, but it doesn't turn black because it's dirty from dirt or anything like that. We'll talk about that tonight. These blow-by products are extremely corrosive, and that's why we have to get them out of the engine. Our aircraft engines produce just about as much water as they consume fuel. So if I'm a Cessna 210 burning 14, 15 gallons an hour at cruise power, the engine is actually producing about that much water. Along with that are very strong acids that are formed when they combine with the metals in the engine, and those items, along with raw fuel, unburned fuel or partially burned fuel, can be highly corrosive to the engine. It forms a strong acid, if you will, that can be corrosive. And we see a lot of cam and lifter distress in engines, more so than we ever have before. I don't know that I can really point my finger to why that is, but I know that the first step in preventing cam and lifter distress is frequent oil changes to rid the engine of these acids. It's my belief that many of the lifters that spall are the result of corrosion pitting. Most metallurgists would concur with my position on that the cam and lifter distress starts with a pit, maybe on the lifter lobe, that starts to break down and delaminate the face, and then that can transfer damage to the cam. Another reason that we change oil is to replace the oil additive chemistry. The oil companies put additives in the oil to break down these acids, and or neutralize, I should say, is a better term, to neutralize the acids within the engine oil. And so when we add a quart of oil along the way, in some ways we're replenishing those additives. Also, at an oil change, it's very important that we replenish that those constituents, those additives. And then after the oil change, we want to start the engine, we want to run the engine, and we want to warm it up, maybe even fly it, check for leaks, but we want to fly it so that we can coat the engine with that replenished oil with those products in here that will neutralize the acid. And probably one of the most important things, or another important thing I should say, is the indication of internal engine health. When we look at the filter, we look at the oil, we look at an oil analysis, those paired together can be a very good indicator of how the engine is functioning on the inside, and if we do or don't have a problem. And so tonight, that's what we're going to talk about. We're going to go into what you can find during an oil change, and how what that may mean to your engine. Let's talk for a minute about the typical tools that the aircraft owner will need to get in order to perform the oil change. Again, anybody can go out and drain the oil and replenish the oil or change the filter, but there are specific things that need to be done and checks that need to be done in order to do it correctly. To do it correctly, you need these typical tools that I'll kind of go through. Number one and foremost is you'll need your respective aircraft maintenance manual. If you're an experimental aircraft, you'll need the engine operations manual or the engine service manual, maintenance manual set forth by the manufacturer. Those items, you need to know what kind of oil, how much oil to put in, and how to service it and how to change the oil. These these tools, or the maintenance manual, can be very beneficial, particularly to someone who doesn't have a whole lot of experience in changing oil, because there are checklists in there that the owner can follow and not miss anything. You'll need to have a set of safety wire pliers, and not only just owning a set of safety wire pliers, but you'll need to become familiar with how to properly safety either the oil filter or the oil screen or the suction screen, whatever set forth by your manufacturer when doing the oil change. So you'll need to be comfortable in performing the safety wire task. You'll need some safety wire. You'll need a calibrated torque wrench. Very important that it be calibrated. Most cities around have a calibration station within the town that will do a large cities will have a calibration facility that will calibrate your torque wrench for you and do it on a regularly scheduled basis. And I certainly recommend that be done. You'll need a 1-inch socket for the oil filter if it's equipped, or you'll need the applicable socket or wrench for the oil screen if your engine is so equipped. The oil strainer plug, correct wrench or socket for that, and a ratchet. Sometimes a socket will work, sometimes a wrench will work. You can't get a socket in there. Sometimes you can't get a wrench in there and only a socket will work. It depends upon your respective engine as to what works best for that. The other items that you'll need is and I can't stress this enough, a clean container to catch the oil. I have seen walk through hangars for years and years and years, and I've seen people performing an oil change and draining oil into the nastiest, dirtiest container that you'd ever want to see. And that's not a good practice, because if if during the oil change we see something that is that would indicate that we need to investigate further, it would sure be nice to have started with a clean container so that we know that everything in that container came out of that engine. I've seen safety wire pieces in there. I've seen Scotch-Brite pieces dumped in, dirt, tools, and you name it in those containers. So in my hangar, I keep a very clean container. It's washed out every time after the oil change. And it is covered so that it stays clean, so that it doesn't get dirt, dust, and things like that. And that's very important. You'll need some diagonal cutters or wire cutters. Some Dow Corning DC4 is good and recommended by most manufacturers to apply a little of that to the base O-ring that or rubber gasket for your oil filter to soften that just a little bit during installation. You'll need a filter. We want to certainly, if we're going to the trouble to replace the oil and change the oil, we want to do the filter at each time, if so equipped. A gasket for the finger screen. If your engine is not equipped with an oil filter, you'll be pulling the finger screen or the strainer screen to inspect it. Another key point is when we take the screen out of the engine, we want to clean it and wash it with clean solvent. Again, walking through hangars over the years, I've seen people over there with nasty solvent trying to clean the finger screen. And it's not so much that I'm worried about getting contaminants in the screen, which I am a little, but more than that is I want whatever I wash out of that screen, I want to capture into a filter or something like that. So take, for example, our J3 Cub or the Stearman or Air Coupe. They don't have a filter, so they have the screen. So I take the screen off. I take usually a coffee filter. I have clean solvent that I have at my hangar, and I run the solvent to rinse the screen into that filter. So any of the constituents that are in that screen are going to go into that filter. And I know that I'm not cross-contaminating with something that's just coming out of the solvent. This is good, clean solvent. And so anything that comes out that's caught is going to be something that came out of the engine. You'll need a crush gasket for the oil screen or the finger screen, needle nose pliers for twisting the safety wire and making the little pigtail so that we don't, when we reach in our cowling, we don't get cut, things like that. They can also be useful in removing some of the crush gaskets if they become nuisance and can't easily come off. An oil analysis kit, I certainly recommend that you have your engines on oil analysis. I think it's a very good indicator of engine health. We'll talk a little bit in detail about, a little later in the presentation, about oil analysis and what that means and how to perform that. But an oil analysis is a cheap insurance for what's going on in the engine. And an oil filter cutting tool. These are available from Aircraft Spruce or any aviation supply house that supplies tools for mechanics. You can get an oil filter cutting tool, and that will, when you remove the filter, you'll take the tool, you'll cut the canister, you'll remove the filter element, and then you'll take a utility knife and cut the pleats out of the filter and then stretch it out. And we'll talk about that a little bit in more detail. But those are the tools that you will need to get started as a kit, if you will, to do your own oil changes as an owner. Let's talk about the proper technique for an oil change. I've actually seen mechanics and owners that just go out and start draining the oil, and the oil really needs to be warm, and not starting the engine and running it just for a few minutes. We actually need to fly the airplane. We need to fly it and get everything up to temperature. and drain the oil when it's warm. When we warm the oil, we decrease the oil's resistance to flow, and so we get more of the oil moving and draining off those parts, carrying with it some of those unwanted acids and combustion byproducts and things like that that we find within the oil. It's carried out because most of the oils that we use is ashless dispersant, carries the oil in suspension, or excuse me, carries the debris and those particles within suspension and down and into our catch can. So always do it when the engine is warm. Always change the filter when you are doing an oil change. It doesn't make any sense to go to the trouble to drain the oil and do all that and not change the filter. I certainly would recommend that each time that you do that and that you open it up to look for an indicator of how the engine's functioning. If you suspect a problem, maybe you had an abnormal filter, or you had an oil analysis that came back and the recommendation from the manufacturer was, really don't think there's a problem, but I think we ought to recheck it in 10 hours. A good practice would be to drain the oil through a clean filter or a cloth that can catch any of the debris and things like that that may be of concern. You don't have to necessarily do it all the time, but if I'm performing just a standard oil change and I cut the filter and I see an abnormal filter or a lot more material than I saw at the last oil change, because I used a clean container, I may then filter that oil through a filter and catch those constituents for examination as well. So be prepared to have some coffee filters or large filters that you could procure to do that. A cheesecloth or a very, very clean lint-free rag can also work as well. And if you do the oil change and you remove the filter, go to the time and trouble to cut the filter and examine it, and use that to your advantage to know what's going on in your engine. And we'll talk about what we're going to learn from looking at that. Now, as I said, examination of the oil and filter will cut the canister away from the element on the inside, and then take a utility knife and we'll cut the paper filter off of that internal canister. And then we lay that filter out. We lay it out on a clean bench, not a greasy, nasty, dirty work table, but a clean bench that's been wiped clean, and stretch that out so that we can look at each and every pleat in that filter to see, well, if we read part numbers, we know we've got a problem, okay? But big chunks of metal, things like that, are very much a cause for concern. But what we're really looking for is, did the oil change? Did the filter change from the last inspection? You know, when we do oil changes on these engines, these air-cooled aircraft engines, they produce metal by nature. That's what they do. If a turbine mechanic, a guy that never worked on recips at all, but just worked on reciprocating engines, or never worked on reciprocating engines and just worked on turbines, if they looked at one of these filters and washed the filter into a dish and looked at the constituents that come out of it, they would ground all the airplanes out flying today, because they do produce metal. But what we're actually looking for is, was there a relative change? Was there more contamination? Was there more particles since the last inspection? And if there was, what were those particles and how can we identify those? An abnormal filter is what I would call something where there was an abrupt change. So we had a few little light specks. If you take it out in the sun, you could see a few specks, normal filter. over and over and over and over and over. And then all of a sudden, we start seeing larger particles, or we see a change in the shape of the particles, more numerous particles within those pleats. That will require a more detailed inspection. If you're concerned about that, one of the things that you can do is take that to your mechanic that is performing your annual inspections or your 100-hour inspections, and say, hey, during the course of this oil change, this is what I noticed in the filter, and get opinion from the airframe and power plant mechanic. And if he's unsure, then the next step would be that you contact the respective engine manufacturer and get their opinion. Some of the engine manufacturers offer the service where you can send half of the filter in, or a sample of that filter in, and they will examine the filter to give you and give the mechanic an idea of the source of the material and maybe where it's coming from, and then you can go, or the mechanic can go and investigate it further. When filters are sent to the manufacturer, many of the manufacturers have at their disposal scanning electron microscopes and things like that can go a long way, but that's really not something that we have to have in order to look at this filter and determine the origin of, or the source of, the material. In fact, most of the time it's washed. The filter sample comes in, and with avgas, or I like to use acetone, the filter is washed into a Petri dish, a clean Petri dish, just like we used to use in science class in high school or college, to look at under a microscope. And so when you wash those constituents in, you wash that filter, you're going to get a lot of residue of oil. There'll be some carbon. It'll be black, very difficult to see. So the technician at the engine manufacturer will rinse that, pour it off, rinse it again, pour it off until he's left with, like in the picture there on the right side, just the constituents that are of interest. The dark oil and some of the carbon deposits and things like that we don't really care about, but we do care about the wear metals and things like that. And that's what we're left with after we wash that. So we'll look at that, and then we'll analyze those constituents. If needed, the respective engine manufacturer may send the sample to the metallurgist and have him determine the actual MHS spec of the metal, or what have you, in order to determine where it comes from. So it's a very, very useful tool. I've looked at these over the course of my career hundreds of times, and you can really tell a lot. You can see a lot. And the first time you wash one of these filters into a Petri dish and you look at it under a microscope, you're going to say, whoa, look at all that material. But again, with the naked eye, it's probably just a normal filter. But again, these engines make metal by nature. I've seen pieces of metal, carbon, glass beads. Wonder where that came from. Somebody blasting or doing a part in the hangar or something, it gets in the engine. Scotch-Brite, see that in oil filters a lot. Paint. Some of the valve springs and some of the manufacturers have paint, and that can flake off, and you have some little red particles in there. That's a very interesting observation. And if you do see red particles, you need to take a little punch or a little sharp pick, and you need to tap those areas under a microscope or under a magnifying glass. And if they break, then they're paint. If they chip away and break and bust up, they're paint. If they're spongy, that could be an elastomer coupler from a alternator drive or something like that. If your engine is so equipped, and that would cause for concern and more investigation. There's a lot that we can learn from the filter, and we take that and we pair that with a oil analysis, and we really learn a lot about our engine. Now let's talk just a minute about an oil analysis. I've seen oil analysis for many years. Some owners opt to have it done by companies that do heavy equipment, diesel engines, and things like that. I don't think that that's a good practice. I think that you're probably better off and better served to go to someone like Aviation Oil Analysis or AvLab or Blackstone or those types of companies to have the oil analysis performed. These people are familiar with aircraft engines, and they're familiar with the testing and what to expect. And some of the diesel engine type of people are not. So instead of doing some industrial generic test, I would certainly opt for an aviation company that does that day in and day out. The oil analysis is balanced with the oil filter. For example, we cut the filter open and wow, it's got a few more flakes and things in it than it did before. Then our oil analysis comes back and one of the wear metals is elevated. And you say, well, yeah, I saw that in the filter. We communicate that with our mechanic. The mechanic may, based on that, know exactly where to go and investigate. It could be something very, very benign. It could be something that there's cause for concern. But we balance the two together, and it works out really, really well to determine the engine health. We can't use the oil analysis as a snapshot either. I field a lot of calls over the years from potential aircraft buyers, and the call would go something like this: hey, I'm so-and-so, and I'm about to buy this Cessna 210, and I'm going to have an oil analysis done. What do you think about that? And then the aircraft's been sitting for 2 years. Well, you know that the engine is going to have higher iron content from rust. You know that that's not going to be very useful because that's just a snapshot of what's going on right now, or what's in the engine right now. The oil analysis, to really be useful, has to be tracked over a period of time. And so what we're doing is, and by the way, you may have a buddy that has an IL 520 or an 0200 engine, or a Lycoming engine has the same aircraft, the same engine that you do, and your may wear less or may wear more than your buddies. Each engine is a little different. The wear material is affected by the tolerancing in the engine. It's affected by the percent power that we cruise at. It's affected by whether we operate in dusty conditions, in the environment, in the heat. So a lot of these things can factor in, and two engines identical can have very different oil analysis. But the real thing we're looking for is, do we have a relative change over time? We're looking for spikes. We're looking for a rise in material. And generally, when we have something that is imminently catastrophic with an engine, something that's going to be really detrimental to the health of the engine, you'll see spikes in several different metals, tin, copper, aluminum, things like that, all trending up and can be very, very concerning. And when you see that, when you have multiple metals that are coming up, that is certainly cause for concern, and contact your respective engine manufacturer. If you go from, let's say, iron, it goes from 40 to 60 or something like that, or 65. And I've actually had people call and say, hey, do I need a new engine because the iron went up? Those are in parts per million. So let's think about that. We went from 40 parts per million of iron to 65 parts per million of iron. Is the sky falling? Probably not. That's parts per million. Let's think about that for a minute. Let's take the room that I'm in right here, and I put 1 million ping pong balls in it, and I paint 65 of those ping pong balls red. I'm going to have a hard time finding that. My point is it's a very minute amount of material. And I'm not making light of a spike or a change, but generally speaking, when we see that, we can always relate that to some function that happened with the engine. For example, a lot of times when I field a call from an owner that has an engine that has accelerated iron, or the iron has risen from 40, you'll go back to my example, from 40 to 65, you find out, yeah, well, I had knee surgery and I didn't fly for 2 months or something like that. And the airplane was sedentary, and that is exactly why. And he's got steel cylinders. They form a little iron oxide. As soon as the engine starts, the cylinders are wiped clean. That stuff gets in the oil, and it's not harmful to the engine. The filter does its job. The oil does its job in carrying those particles in suspension, and when we change the oil, we get rid of it. So we have to take these oil analysis very, very seriously. Don't use them as a snapshot. When you sign up to do oil analysis, you're signing up for the long haul, that you'll do it at each time at regularly scheduled intervals. I also like to stay with the respective oil analysis company that I start with. I've seen owners that have it done here, and then they have it done here, and then they have it done here. And there can be some variability in the way they do the tests. And I just don't think that's healthy to do that. I think you stay with the same company that you start with. You try to get it as close as you can for oil time. If you go over an hour or two, it's not that big a deal. But you don't want to present an oil analysis where you did it at 25 hours and then you did it again at 54 hours or something like that. That can be a little meaningless to the oil analysis company, and the data is really not useful in tracking this over time. So let's look at some of the common sources of material that we find in a typical oil analysis. Some of the constituents that we can find. These are not all of them, but these are probably the most popular that I see. Without a doubt, the biggest call and the biggest concern that I get over the years is my iron content has changed. And that's typically from the cylinders. It's typically from a little bit of rust. You folks have seen some of my presentations before. You know that I live in Mobile, Alabama. I'm actually here tonight at the factory at Superior Air Parts in Dallas, Texas. But both Dallas and Mobile, Alabama are fairly humid climates, and it's not uncommon to get a little iron oxide on the cylinders during periods of inactivity. It's not going to be the end of the world, but it does affect the iron content and it can elevate that. It can come from rotating steel parts, valve train. Any steel part that's coming in contact with the oil is subject to produce a little iron oxide. Generally speaking, this is not something to have a whole lot of concern about. I've seen it in several hundred parts per million and still be a benign oil analysis. Again, we're talking about parts per million. But here's again where we take the oil analysis and we apply that to our mechanic. We, the owner, did the oil change. We did the oil analysis. The iron came back. Let's say it came back 100 and something parts, 150 parts or whatever. We then can communicate that with the mechanic, and the mechanic can perform a borescope inspection of the cylinders to see if, hey, got some iron oxide, but you don't have any rust pitting. I think we're good to go. Things like that. Those types of conversations happen all the time, and I encourage you to do that. Copper and brass are the only place they can come from in the engine or the bushings, in the bearings and the oil coolers. Typically, the brass and bronze that we see is from some type of bushing. It may be from a rocker arm bushing. It may be from a starter adapter bushing if you have a Continental engine, things like that. Nickel will come from valve guides. And if some cylinder types, there are some cylinders that are nickel plated. And if you start to see elevated nickel, that can be a big cause for concern, especially if the nickel is peeling from the cylinders. If your nickel goes up, boy, you want to get in touch with your mechanic and really start to look at borescope the cylinders and make sure that we don't have, if you have nickel cylinders, that we're not peeling the nickel off of the barrels. That can be extremely damaging to the internal parts of the engine, to the bearings, to the whole engine. And generally speaking, if you find that you've had some nickel peel on a nickel cylinder, you're done. It's an engine teardown in order to correct that. Chromium comes from the rings. That could be from too aggressive hone pattern or roughness in the cylinders. It also can come from paint. Sometimes we'll get a chromium level that is elevated, and when questioning the owner, has anybody been painting? Oh yeah, my hangar mate, painted his airplane and blah, blah, blah. That paint has chromium in it and can actually get in the engine and elevate the oil sample. Magnesium usually comes from engine casings, castings, like the accessory case or some of the old sumps on some of the old Continentals, but primarily it's an additive. That's one of the additives that is in oil that allows for the neutralizing of those combustion byproduct additives. Aluminum is a very common thing that we can see in a filter and also in the oil analysis. If you see some aluminum slivers within the oil filter, that's most likely coming from the piston pin plugs. That can be verified with a borescope inspection. Your mechanic will pay particular attention to the 3 in the 9 o'clock position, excuse me, 3 and 9 o'clock position during the borescope to see if he's got any scuffing or you have any scuffing going on in the cylinder. Lead is also a primary thing that is reported, and that's generally gas blow-by. It can come from traces of the alloy that is in bearings, but most of the time it's just the lead that's in the avgas is blowing by in the form of raw or unburned fuel. Silicon is a very important element that we need to look at within the oil analysis, because this is dirt. This, when I look at this can be the intake or the filter, those types of things. It can also come from the sample contamination. Remember, am I kind of harping on the clean container for the oil change? This can be very problematic if the sample is contaminated with a dirty bucket or dirty container. Tin is bearings, bronze parts, sometimes paired with copper. Some of the anti-wear coatings that some of the internal engine parts have can contain some tin. A little tin doesn't mean the bearings are coming apart, but if we have tin paired with, some aluminum and other constituents that are rising, then that may be a cause for concern. Another thing that I had today, had a customer that knew that we were doing this tonight and sent a note to me regarding an elevated calcium level in his oil analysis. And I've never really looked at the calcium level in it, but his was fairly high, but not something that needs to worry about, because that is the acid neutralizer additive that is in the oil, and the oil companies put that in there to take out and neutralize some of those unwanted and highly corrosive items that by nature the aircraft engine produces. When you look at the aircraft engine compared to a automobile engine, it's quite different in its tolerancing. I think that on my wife's car now, there's 10,000 miles recommendation between oil changes. And if you equate that to time, that may be something like 200 to 300 hours on the engine without an oil change. But we would say we'd never do that with an aircraft engine. Oh, we got to change the oil at 50, or if you don't have a filter, we got to do it at 25. That's true, but we have a whole different animal that we're talking about with the aircraft engine compared to the automobile engine. The tolerancing is much tighter. The amount of blow by that goes by in the automobile pales in comparison to what gets by in the aircraft engine, and that's by nature, by design. Also, we're using leaded fuel to suppress detonation, something that we don't have to do within our automobiles. Monitor your oil consumption rates during the oil change and in between. This is very, very important. I keep a little log in all of our airplanes, that when I add a quart of oil, I know exactly when I added it. And this, paired with the oil analysis, paired with the looking at the filter, if I've got a relative change in oil consumption, I need to be communicating that to my mechanic, either at the time it happens or at the annual. Hey, at annual time, Mr. Mechanic, my oil consumption went from 7 hours to add a quart to 2 hours to add a quart. That's good information that the mechanic needs to know. And you need to keep that log so you know exactly how much oil you know. No, don't guess at it. Actually know what those hours are. And that's very beneficial to your mechanic. Just because the oil consumption went crazy does not necessarily mean that you've got a cylinder problem. We could have a crankshaft seal that's leaking. We could have an oil filler cap that's not sealing properly. We could have a host of different things that could be causing crankcase pressure to dump a little oil over. Sometimes just routing of the breather or a stopped up breather or something like that can cause crankcase pressure to go up and form some leaks and things like that, lead to higher oil consumption. So it doesn't mean the end of the world all the time just because we start using oil. By nature, these engines do use oil. I'd say the universal average, the center of the goalpost, is something like a quart in 7. Each engine has a maximum specific maximum brake specific oil consumption that's calculated using a long formula based on percent power and things like that. And what it works out to be is about a quart an hour. Or the way I like to think about it is, if you have to stop for oil before you stop for gas, you probably got a problem. And that's how engines are actually certified, is even at that maximum brake specific oil consumption, say a quart an hour, the aircraft will exhaust itself of fuel before it would run out of oil at that rate. So very important to, along with the oil change, to monitor those consumption rates and communicate that information to our maintenance provider. Another typical question with regards to oil changes is, I'm asked all the time, what oil do you recommend? Well, none of the oil companies came in and made a contribution to my daughter's tuition at the University of Alabama. So I don't have really a favorite. And all of the aviation oils meet these, the mill specifications. All of them are very good oils. In fact, there was a study done many years ago where they took, I forget the company did, I think it was actually an oil analysis company, looked at about 300 different engines with varying amounts of, or varying oil brands, and looked at the wear materials, and they all came in very, very close. There was no big change from one brand to the other. So brands, as long as they meet the mil spec set forth in your respective operations manual, you're not going to have a problem, and it's okay to use it. But to find out what to use, consult the engine manufacturer. And if it's a Superior aircraft, a Superior Air Parts engine, you look at our operations manuals contained within that, the grade, the type based on the atmospheric conditions, and the mil spec, what it needs to meet. Continental has a manual that's M-0, There's a subscription fee for that, but that's good information. You need to, if you have a Continental, certainly have that document. And if you're driving a Lycoming powered aircraft, the SL 1014 tells you exactly what to use in the engine, and follow those to the T. Typical intervals would be a screen 25 hours, an oil filter every 50 hours. And most oil companies recommend, and engine manufacturers, that we not exceed 6 months. Induction system inspection. Let's go back just for a minute and talk about the silicon. You remember I said that the silicon level, we see a oil analysis and the silicon level has risen. We need to investigate the filter, make sure that the filter is clean, that it's been changed regularly, and that it's fitting properly. Look at the alternate air door rigging, look at the carburetor heat rigging and things like that. If we have our mission calls for landing on unimproved aircraft runways, then we need to make sure that when we land, we get the carburetor heat off as soon as possible so that we're not sucking in unfiltered air and things like that. So we can learn a lot from the oil analysis. You got elevated silicon, it's time to start looking at looking at those, that induction system. Those unfiltered element, or those unfiltered constituents that get in the engine, can be highly abrasive and damaging to the engine. So you want to limit that as much as you can. Engine cooling and baffles is also very important. We want to target cylinder head temperatures that are not too cold and not too hot. You know, we are obsessed in the industry with taking care of our engines and being kind to them. And for the most part, most of us think that cooler is better. That's not always the case. I've heard people boasting and bragging about, oh, I have cylinder head temperatures of 330 degrees Fahrenheit, but they're walking around with oil temperatures at 160 or 150 or something like that. And that's not warm enough in order to start to boil off some of those unwanted combustion deposits, water, and acids that we get from the blow-by. Most aircraft engine manufacturers and the oil companies would like to see 180 degrees systemic oil temperature. That provides a good temperature to cook those unwanted things out of the oil. So look at that. Being super kind, it's not always a good thing. Also, we don't want to get it too hot. You know, it's not uncommon in a hot summer day during climb out that we can go over 400 degrees in some of our engines, depending on what you're flying. But in cruise flight, a general rule of thumb is that any engine should run at or below its max cruise power setting, either at a best power or best economy mode, run smooth, and have a temperature of less than 400 degrees Fahrenheit. If you're not able to do that, you probably have a fuel delivery problem, maybe a timing issue, or maybe a baffling issue, and that needs to be investigated. But we want to target those cylinder head temperatures set forth by the manufacturer. And those are there in order to provide good oil temperature to cook that stuff out. Now, one final note is when you're doing an oil change, if you as an owner are unfamiliar and you're uncomfortable with doing an oil change, you can get your mechanic to mentor you, to help you with a few oil changes, 1 or 2 or however many you need, to make sure that you're comfortable and confident in doing that. Again, you need to be following the manufacturer's recommendation and the checklists to ensure that all the items are completed. Believe it or not, you would be surprised at the number of times that even A&P mechanics have provided or completed an oil change and they forget to put oil in the engine, and they start the engine and they trash the engine in very short order because they didn't put oil in it. It happens more often than you think. But if you follow that checklist, the last thing will be service the oil or service the engine with 8 quarts Aeroshell, 8 quarts Phillips Cross Country, whatever. Follow that checklist. It is important. You'd be surprised at the number of times that happens. So, owners, and operators, I think it's important that you adhere to manufacturer's recommendations for how to operate, the maintenance recommendations that are set forth by your respective manufacturer. If you have somebody that comes up to you and says, oh, you don't need to do that, or you ought to do it this way, and that is contrary to what is written chapter and verse in your manufacturer's recommendation, you should question the validity of that and consult your manufacturer to see if that's healthy for your engine. Folks, this will only lead to enhanced safety, reduce life cycle costs, and improve reliability. And that's what we really want. That's the goal here tonight. If anything at all, that we, those things is what we're aiming for here. Just a quick word about Superior Air Parts. We have thousands of FAA approved PMA parts that we manufacture and sell. We do manufacture the Millennium cylinder for both Continental and Lycoming powered engines. They come with a 37-month warranty, industry-leading warranty, and they're great cylinders, aluminum alloy heads, and through hardened steel barrels. A really, really nice looking cylinder as well. You can go to our website. I recommend that you do so at superiораirparts.com for two reasons. Number one, you can click, if you look there at the screen, there's a book, Engine Management 101. And I was challenged by Superior Air Parts to put some of my thoughts together of some of the presentations and some of the things that I've learned throughout my aviation career into a little handbook. And you can click on that link and get your free digital copy of Engine Management 101. We've never charged for that. And the spirit in which that book was put together was to try and help you as owners to dispel a lot of the myths and a lot of the information that can be very confusing on what we should be doing. We talk about oil changes and some of the things that I've talked about tonight. We talk about how to operate your engine and lean it and all kinds of things that I think you'll find beneficial. If nothing else, hopefully it'll provide a foundation for you to ask good questions of your maintenance provider. The second reason to go to our website is to look at our eligibilities and some of our documents there under technical support. You can hover under technical support and click on Superior eligibilities. If you ever wonder, does Superior make cylinders for my engine? It's answered very, very quickly by either looking by engine type or by the part number, and enter that. And then you can see if we actually make something for your engine. You'll see the models that we have eligibility on. You can click on the PMA document. You can see the kits that may have that part number in it, and each kit is broken down so you know exactly what comes with it, like this cylinder kit on the screen now. You'll see everything that comes with it, and for that particular part number, what engine that it fits. I thank you for your attendance tonight. I know on behalf of myself and all the employees here at Superior Air Parts, we really appreciate you, those that use our parts, and attending tonight. I hope that you folks got something out of it. And Kent, right now, I'll take questions.
Let's see here. The first question from Mark Lisa. Tempest filters say no gasket lubrication is needed.
That is totally correct. And thank you, Mark and Lisa, for bringing that point up. The Tempest filter comes with now, it's called an easy spin, and it's pre-lubricated in order to make it very easy for removal. But if you're using a Champion filter or some other, you certainly want to use a DC4 or some oil if you don't have it, but DC4 works really, really well.
Okay, Bill, let's see here. From Michael McRobert. What are Bill's thoughts towards using one's engine heater in cowling blankets, such as a Tannis system, to warm the oil before draining rather than flying first?
And that is an excellent question, and I would be totally against using a Tannis heater to warm the oil. The the use of a tannis, and this has been a long debate for many, many years as to whether a tannis heater can, or any heater, I'm not picking on tannis, but whether an engine preheater can cause corrosive attack. If you use your heater, engine heater, improperly, you can warm the oil just to the point where it will create what I like to refer to as a nasty acidic rainforest inside the engine, where we've warmed the engine or warmed the oil just enough to start to off gas, and that stuff can be very, very corrosive. It will not get the engine up to the temperature that you would get it to when you're flying. At least the heaters systems that I've seen before don't allow for that, and so nor is that something recommended by any manufacturer that I'm aware of. Now, if a engine manufacturer says that's acceptable, I would assume that they've done testing and have okayed that. But off the cuff, I don't think that would be a very good practice. I think the aircraft should be flown and the engine warmed to normal operational temperature, and then the oil drained.
Okay. Thank you, Bill. I appreciate that.
Mm-hmm.
We've got quite a few upvotes on this one. How do you feel about cam guard?
I knew that was coming. And I'm going to tell you a funny story that happened. Don't mean to make a short story long, but you know me, Kent, that's what I do.
That's right.
I was at Oshkosh one time, and I was working the booth answering questions from customers, and a customer came in and asked one of the reps that worked with me, what do you think about cam guard? And the rep said, snake oil, don't use it. And the guy walked away. And I called him off to the side and I said, wouldn't it be better to answer that question that we have not tested cam guard and that we don't know, because we haven't tested it, we don't know what its effects would be and things like that. At the time, that actually worked for a different engine manufacturer at the time. And out of that story, I contacted CamGuard and we entered a test using overhauled engines and put them on CamGuard. We had the engineering department analyze the product and to ensure that it wouldn't do any harm to the engine, and then we proceeded with the test. The results of the test were promising, and I left that engine manufacturer to take the position here at Superior before that was concluded. Now, Superior's official position is that I can't endorse it or recommend it because we as a company have not performed any testing. So with that said, I would recommend that those that are contemplating using an oil additive, such as CamGuard, that they contact CamGuard and talk to those engineers regarding the product and what the expectations of that product and its benefits would be. CamGuard is one that has an excellent group of people that they can talk to get that information and make that informed decision.
Excellent. Thank you, Bill.
Mm-hmm.
Another one, quite a few upvotes. After I shut down the engine and take off the oil cap, they put a rag mostly over the filler neck to let the humidity out. Good or bad idea?
I've seen people and know of many people doing this. And what they're talking about is when the engine oil is hot, they can oil the cap, and a lot of times you'll see steam and vapor coming out of the filler cap. And the person asking this question probably had a filler cap that rusted on the inside because of this vapor. I know a lot of people that do that. I don't with my airplanes. I keep the oil changed pretty regularly. I try to fly them fairly regularly. But I know a lot of people that do that. If you're going to do that, I don't see any harm other than when you take the cap off and you leave it, you don't want a dust storm going on or something like that. Putting the rag over it, I think, is an excellent idea to prevent FOD in the engine. But an open hole like the filler cap being removed can be a source of contamination. I would just make sure that, we don't have a lot of wind blowing. Maybe put the airplane in a hangar where there's no chance of any FOD getting in, and put a rag over it like the person said, I think is probably fine. I don't see any harm in doing that. The benefit of it is it probably won't rust the oil cap, the interior of the oil cap.
Okay, thank you, Bill. Let's see here. Do lean of peak operations arguably reduce blow-by byproducts that end up in your oil?
That's a very good question, and it's one that's been debated for a long, long time. When you run lean of peak, and there's nothing wrong with running lean of peak. I've done it all my flying career in as a charter pilot and corporate pilot. I mostly flew piston engine aircraft, twin engine piston aircraft, and we flew lean of peak and best economy back in the 80s. So nothing new there. What you need to be cognizant of is when you're running lean of peak is the manufacturers have set parameters for those engines that are approved for lean of peak operations for best economy. And what I mean by that is that when they are running lean of peak, they're on the bottom or the brake specific fuel consumption curve is at the bottom. It's at the lowest number that you can possibly be. The engine is the most efficient. What happens and what I've seen where this can be problematic is when we're chasing cylinder head temperatures. I've seen owners, they say, well, I know Continental says 50 degrees lean of peak, or I know Superior says 50 degrees lean of peak, but if I run 125 degrees lean of peak, my cylinder head temperatures get down to 350 or 360, and I just think that's better. Well, number one, oil temperature can fall, but you also lose combustion pressure, and combustion pressure can affect the ring sealing, the ring seating on the piston land, and the ring seating against the cylinder wall. So if you get into a point where you're reducing that combustion pressure, then you can accelerate blow-by. And I've actually performed engine examinations on engines that were operated outside of manufacturer's recommendations where the oil control ring was coagulated and frozen due to the excessive blow-by, due to the low combustion pressure. The ring actually would cavitate, the engine would bump once in a while. The manufacturers have set those parameters for running. If they say 50 degrees lean of peak, pick a number, it depends on the engine, that the combustion pressure is adequate and the engine is running in the most efficient manner. And again, it should be at a cylinder head temperature of 400 degrees or less, unless there's a problem going on with the engine. So to answer the question, and I know I made another short story long, I apologize, Kent, but it's a very good question. As long as you're running in accordance with the manufacturer's recommendations, there should be no difference in the amount of combustion blow-by. When you're running best power, as opposed to running lean of peak, we run on the best power side of the curve, the combustion pressure is higher. Higher combustion pressure is not a four-letter word. It actually seals the rings and squeezes them against the cylinder walls much tighter against the piston ring lands than on the lean of peak side. So, again, at the end of the day, I don't think you're going to see an appreciable change in combustion blow-by or things getting past the rings, as long as we're operating within those envelopes set forth by the manufacturer.
Great, thank you. And we love the long story answers because there's a lot of information in there. Another big question here. Is there a longevity dividend for changing oil at 25 hours, even though it has a spin-on filter?
That's a very good question. Um, if you have a spin-on filter, and the reason I say it's a good question is it's a very loaded question because there's a lot of factors that need to come into play than the fact that we just have a spin-on oil filter. Are we operating in dusty conditions off of unimproved strips? Are we using the aircraft in a utilitarian fashion, carrying high loads, high cylinder head temperatures, really abusive to the engine? Those types of questions need to be answered. But typically, the more frequent that we change the oil, I think that would probably lead to more longevity of the engine. Um, 25 hours, we also have to consider the calendar time. I've heard some folks that have written white papers that suggest 4 months. The oil companies uh, generally recommend 6 months. Um, and I think that if they were in it for some alternative reason, they would recommend that we do it every 10 minutes, and so they can sell more oil. But I think the proof is in the pudding, and the field performance data that's both the engine manufacturers and the oil companies have received is 25 hours for a screen, a filter 50, no more than 6 months is a good guide. I don't think that you'll gain a whole lot by doing it more frequently with a filter. But we have to consider some of those variables that I mentioned.
Right. Thanks, Phil. Um, I'm a relatively new pilot who co-owns an older Cessna 172 with an experienced pilot. The manual for the plane calls for 6 to 8 quarts of oil. However, my co-owner says 5 quarts is fine and that the engine can run quite well on 4 quarts. He says that if we put in more than 5 quarts of oil, we'll just be wasting it. It'll probably just blow out.
And it will. And that is a very good question. I touched on that briefly during the presentation, but I didn't expand on that. When I was a student pilot, I always wondered that too. Why is the mechanic telling me to only put 5 quarts in when it takes 6 or 7? Fill it up. I want to fill the oil up. I want all the oil in the engine that I can have. The simple fact is the reason that aircraft engines blow that quart or 2 quarts out, or they get to that sweet spot, if you will, where they don't dump oil, has to do with the certification of the engine. If we go back when I was talking earlier, I talked about the fact that the aircraft must run out of fuel before you run out of oil, even at maximum brake specific oil consumption. And that's how sump capacity is determined. And that to obtain that, some manufacturers have to have a little more oil capacity than the engine really needs for normal operation. And it's okay as long as it will stabilize and not go any lower than the 5 or the 4 quart mark, is fine. I'm assuming that he's maybe had an 0300 or an 0320 Lycoming or an 0300 Continental, and there are in the type certificate data sheet for any of you, you can look at the minimum oil for the engine, and that's generally based on an angle up and angle down attitude of the aircraft. You certainly never want to get near that, but it can be relatively low. I think that a 7 quart sump or an 8 quart sump and stabilizing at 5 or 6 is probably very, very normal, and it has to do with the certification requirements and sump capacity. That's why they blow that last quart out.
Okay. This is a kind of a loaded question. Does Bill have an opinion towards taping off, whoops, taping off part of the oil cooler to maintain temperatures above 180. Their target is 180 to 210.
Yes, and that practice is done all the time. Um, Part of the problem that we have, and this is another excellent question. These questions are really really good. Um, Part of the problem is that some of our aircraft are extremely fast. The baffling is extremely well made. The cylinders, I know the cylinders that we produce have hardly any porosity, so they conduct and dissipate heat very well. Um, so the engines tend to run cooler as a result of some of those factors. And I've known folks that have had aircraft and there's nothing that they can do with the throttle or the mixture control to really affect enough heat. So they can, in typical winter months, especially, tape portions of the cooler in order to help facilitate a normal oil temperature, something in the 180 or above. Um, in doing that, the only caution that I would suggest is that we be very, very careful, that we monitor that very closely, that if we've got a taped oil cooler, that we're cognizant of that and we don't climb at steep angles on hot days and things like that, or we remove it when we're in environmental conditions where the aircraft is subject to run hotter, and just be careful with that. But I know pilots, mechanics that do it all the time, day in and day out. The other thing with that is there's not much data out there from manufacturers on doing that properly. So again, that's why I would say please do err on the side of safety and caution if you do that.
Right. Okay. Thanks, Bill. James Long. He says that they fly 2 to 3 hours per week. How often should we change our oil? And he said they do have a filter.
2 to 3 hours per week. He's lucky. He gets a nice avgas allowance. I don't normally get that much. That's good. You know, the sedentary engines probably have more open themselves up for more corrosive attack and problems reaching TBO than those that are flown on a regularly scheduled basis. There is an airline that um, operates some 402s, and they fly probably 100 hours a month or something like that, you know, extraordinary times. I've heard of some of these carriers going 100 hours between oil changes because the engines are constantly up at temperature and things like that. I think if he has a filter, or these people have a filter, that the 50-hour mark is going to be fine. I would still change it at the 50-hour mark. 2 to 3 hours a week is a good healthy exercise for the engine.
Okay, great, thanks. Let's see here, Eric. What would you use as a threshold for determining how much metal in a filter justifies calling the engine manufacturer?
That's a good question. Lycoming actually published a bulletin, and I don't recall the number. I'm sure you could do a Google search, but Lycoming does have a acceptable, or a guide, I should say, not necessarily acceptable, but a guide for the amount of oil that you find in a filter, and that may be useful. The what I tell people is that you know, if you've established a baseline and that changes, that's cause for concern. If it's the first time that you've ever done it and you've got metal and slivers and things in each pleat, that's a cause for concern. But we've never ever successfully said you can have 300 flakes of this and 200 flakes of that. Typically, most of the engine manufacturers have never come up with that. That is a judgment call on the side of the the owner and ultimately of the mechanic. My recommendation would be that if there is something concerning or something that has changed, or the perception is this filter is abnormal, that you consult a experienced and qualified airframe and power plant mechanic to look at that filter.
Okay.
Or and then based on what they say, then contact the respective engine manufacturer.
Okay. Let's see here. Michael, I think you touched on one of your slides. You touched on this. You hear everything from 25 to 50 hours between oil changes. What's Bill's recommendation? A recommended oil change recommendation for engine with a oil filter.
50 hours or 6 months. Mm-hmm.
Okay. Okay. Paul Schilling says, can you confirm 1 quart per hour sounds high to me?
Yes, I did say 1 quart per hour in most most engines. And this was actually this question, and this is no joke. This question was asked of me when I was right out of high school. Before going to college, I went and got my A&P. So I went through a 21-month program to get that. And the examiner for my airframe and power plant, the oral portion of it, he asked me what about oil and maximum oil consumption in a piston engine. And I rattled off that, using the respective engine manufacturer's formula for calculating the percent power and things like that, you can calculate that. In every calculation that I've ever done on engines, it comes down to about a quart an hour. And so I said to him that this is the way I would do that. And this guy was a crusty old fella. And he says, well, what I wanted you to say was, if you have to stop for oil before you stop for gas, you've got a problem. And that really was his reply to me. I certainly passed and got my A&P, but that was kind of drove home. When you're at a quart per hour, you're at maximum brake specific oil consumption, and it's time to investigate that. Certainly, even maybe before that, as we approach that mark, it needs to be investigated. That may or may not include or have a cause for a top overhaul. Just because an engine uses oil doesn't mean that the cylinders are not healthy. There can be a host of things that can cause high oil consumption.
Okay. Jim Long, you mentioned using a Tannis preheat. I have 4 planes with Tannis. I was told by Tannis I should leave it plugged in at all times below 50 degrees. Do you feel the same way, or just turn on a few hours before flight? And if in 40 degree, it's a 40-degree heated hangar, should I preheat?
In a 40-degree heated hangar, there's no need to preheat at all. And the way I answer that question is you need to follow the heater manufacturer's recommendations on how to operate that. I have always been very, very leery of leaving them on for extended periods of time. But if Tannis has okayed that, then it's probably one that will not cause the acidic attack that I've seen in others. Now, some of the systems that I've seen years and years ago were old type technology. They didn't uniformly heat the oil, and therefore the oil was heated to a threshold where it would off gas and create a nasty acidic environment. And we've seen engines that have been damaged with some of those systems. If Tannis is told you to plug it in and leave it in, I would go ahead and do that. But also at a 40-degree hangar, there's no cause to do that. No reason to preheat.
Okay. Michael, he says that he had to replace a single cylinder. Will I have additional material in the oil and how long?
That's a very good question. And after a cylinder change or a lot of aircraft maintenance, a starter adapter change or something like that, it's not uncommon to see the wear metals increase. Maybe some material in the filter, bronze, uh, brass from bushings and things like that is not uncommon. Generally, those will clear themselves out after the first oil change. So, say 25 hours, that should start to subside.
Okay, okay, great. Uh, somebody has said that their mechanic does not like to change hot oil. He prefers it to be cold. Any issues with that?
Yes, it goes against the grain of the engine manufacturers. Um, and sure, the mechanic doesn't want to get his hands burned, um, but that's not a good way to change the oil. And warming the oil when the oil is cold or at room temperature, it it has resistance to flow. Its viscosity is higher, so it is likely that we would drain more of the constituents, the unwanted constituents in the oil out and to be carried out if the engine is warm. There's a lot of nicks and crannies and things like that, and areas in the engine where when the oil has a high resistance to flow are not going to rid the engine of that.
Okay. Let's see here. Ron, I use a magnet to probe the drained oil and filter. This has produced interesting results. Your thoughts?
It's a good practice. Ron, I've done the same thing. It's a good point that you make there. On my Stearman, it has a W670 Continental, and the front sump drain is very, very hard because of the way the airplane sits to get that oil out, all of it. And I do the same thing only on that particular engine. I actually fish a magnet in there just to see that I don't have a big chunk of metal that's lurking in there. Um, I learned that from an older mechanic that was working on radial engines, and I've done that. I see nothing wrong with that in in rolling it around in the bucket and looking for pieces of material. Now it won't pick up aluminum, and Ron need to be understand that it won't pick up aluminum. So in in with that, if you're concerned about parts being in there, I would certainly strain the oil through a cheesecloth or a filter or a clean lint-free rag to make sure that there's nothing else in there. But yeah, there's nothing wrong with that practice at all, and I do it as well.
Okay, great. Thanks. Tom is asking, have there been any tests done with the use of Marvel Mystery Oil as a fuel and or oil additive, good or bad?
Superior Air Parts is not tested Marvel Mystery Oil. I'll make a short story long again. I have, again, I have a Stearman with a W670 radial. I have, we actually have 5 Stearmans at the airport that I live at. And one of the other gentlemen has a 220 Continental in his Stearman. And he religiously puts Marvel Mystery Oil in his fuel at every fueling, and he doesn't have any problems. I don't put Marvel Mystery Oil in mine, and I don't have any problems. Marvel Mystery Oil, from a chemical point of view, is a very, very lightweight. I've heard referred to as sewing machine oil, but it's a very, very lightweight oil with wintergreen fragrance, and that's all it is. I have read an engineering paper. I think it was Sacramento Sky Ranch, Dave Schwanner. They're no longer in the business, but he's written some very good. He wrote a very good book, the Sky Ranch Engineering Manual. I think that's where I read that you have to be very, very careful in using some of those products in the dosing. Depending upon how much you put in there, you could actually affect the octane rating of the fuel. I don't know that you could hurt the engine by putting that stuff in the oil, but I don't know if you would get any benefit. I just don't know. But putting it in the fuel, the only drawback that I see is that if you're dosing it higher than you should, you could change the octane rating and perhaps set up a scenario for some detonation. So I'd be very, very careful about that. But other than that, I've done no studies myself to tell you whether it's good, bad, or indifferent. We just haven't tested it.
Okay. There's another question. This is interesting. Any reason not to use a trash bag as a liner for a 5-gallon bucket to drain oil into toward keeping a clean environment?
No, that's a good idea. In fact, one of the aircraft that I own, to take the filter off, I use a gallon freezer bag so that I catch all of the oil in that bag as the filter begins to come off. And I want to make a point about that. And I really appreciate this question because I know, first off, the trash bag is an excellent idea, and I see no problem with that. But let's talk about the filter removal for just a minute. You never, ever, ever want to punch a hole in the filter to drain the oil. Get a freezer bag and put it around the filter as you remove it and catch that oil. I know it's messy, but you want to catch that oil. Here's what happens when people take a sharp punch and they stab the oil filter. I've actually seen them hit that too hard and push filter media into the inlet of the pump. And when the engine starts, the little piece of filter gets sucked up and it can block the oil feed in a Continental, particularly to the starter adapter oil feed, because that's a very small oil orifice that supplies oil to the starter adapter. I've actually seen it block connecting rod oil and starve the engine for oil. So be very, very, very careful. Tempest actually developed, when this problem started many years ago, I actually talked with Tempest about this. They developed a little tool that you can put around the filter, and it's got a place for a hose, and you can open up the filter by turning a screw, and it pushes just a little dimple hole in. It doesn't go very far. And people tell me, well, I'm not hitting it very hard. Well, show me the calibration sticker on your elbow. Some big brawny guy or something like that can hit that too hard, and it's just not a good practice. I know it's messy for a lot of the engines, but if you take a gallon freezer bag and wrap it around the filter and just twist it all at one time, most of that will be contained within that bag, and it's not a mess. But never punch a hole in a filter.
Okay, great. Oh, right here. Let's see here. We got a lot in here. I got a lost spot. How is changing my oil every 30 hours or so? No, I'm sorry. This guy says, wow, I'm changing my oil every 30 hours or so. He's going to 0360 on a Cherokee 180. So with your recommendations, every 30 hours.
Yeah. Now keep in mind that these are not Bill Ross's recommendations. These are recommendations by the respective engine manufacturers and the oil companies. But that's an excellent point when we talk about the 30-hour mark. In one of the first slides, I talked about replenishing the chemistry package, if you will, of the oil, those detergents and those elements that are put in the oil to neutralize acid. Some of the oil analysis companies have the ability to perform tests on the oil to see if those emulsifiers and some of those additives are still active in the oil. And if you get on an oil analysis program and they're doing that, the oil analysis company may tell you, you only need to change your oil every 63 and a half hours, or you need to change your oil at every 37 hours or something like that. but over time they can look and see how healthy is the oil from an additive point of view, because the viscosity and the lubricating properties of the oil don't change. What changes is the additives that neutralize these acids and things like that, and some of those um, additives that hold particles in suspension, they tend to um, break down and become non-existent and aren't working. If you use an oil analysis that is looking at that type of data, they can recommend an exact time for oil change, and you're fine to do that as long as you're within reasonable confines of what's set forth by the manufacturer.
Okay. Tom asks, is there an approved synthetic oil for aviation engines?
There is approved semi-synthetic oil. I don't know of a synthetic oil. There's a debate, and has been for quite some time, whether a mineral-based oil or synthetic oil is better for an aircraft engine. But I'm not aware of a full synthetic oil that's available. With the tolerancing in the air-cooled engines that we have, the mineral-based oils tend to do better from a field performance point of view than some of the semi-synthetic blends that we've seen.
Okay. Is it a good idea to fill a new filter with fresh oil before installing?
I've heard of people doing that. If it's recommended by the engine manufacturer, absolutely do it. It's not something that I've ever done. Um, the That's certainly opening up Pandora's box for a mess. I like to put on a dry filter because once I start the engine and run it, I'm looking for leaks. And if I'm sloshing around oil and things like that, that may, I have to clean that very, very well before I can actually do a leak check. If the manufacturer says do it, absolutely, but I see no reason to do that.
Okay. Somebody wants to know, do you fly your planes lean of peak?
My airplanes, I can't fly lean of peak because I have a carbureted 182 and it's incapable of running lean of peak. So I fly it at best power. The Stearman, I run at best power. It's not a lean of peak engine. And the Cub has no mixture control. And the Air Coupe doesn't, and Champ wouldn't do that either. However, as a corporate pilot and charter pilot for different companies, I flew Lena Peak all the time successfully without any problems. And if I owned a aircraft that was capable of flying Lena Peak, fuel injected engine that um, was capable of that, I would do it and not think a thing about it. That's what the engine was designed to do, to put you in the best economy realm. Not every engine, though, is designed to run Lena Peak in its best economy. If those of you who've watched the um, uh, seminar that I did regarding engine leaning, there are airplanes that will not and should not run Lena Peak, not necessarily because they won't. I mean, they can certainly get on the lean side of peak and run smooth, but that's not the most efficient place to run them in their airframe and engine combination. An example of that would be a Cessna 402 with a TSI 0520 Victor Bravo engine. That's its best economy is at peak exhaust gas temperature. So it depends upon the mission. To answer the question, if I had an airplane that had that, absolutely I'd do it and no problems.
Okay. Juan says he lives in South Florida, and the hottest he can get his oil temperature is about 172 degrees on an average. My oil analysis shows 0% water. Should I feel reassured that I'm burning off water despite not reaching 180?
I don't know that water is something that we would want to look at. I think I would look at iron, the iron level um, in this particular case rather than the water. Um, if he's if the iron is above the average, then it's probably not hot enough. I would probably configure or discuss with a mechanic that I'm only reading 172, and then troubleshoot with the mechanic as to why. One of the first things that I would do if the customer came to me would be to get an external gauge on it, equip the engine with that to see what is really the reading, make sure that the gauge is reading properly and that it is actually 172. You'd be surprised at the errors that we find in some of those gauges. And I would use a calibrated gauge to check it. And then I would look at baffling and things like that I could do change to get the oil temperature up. Maybe operational practices may change to get the temperature up.
Okay. And this is going back on the Marvel Mystery Oil. Two people kind of chimed in and said that Marvel Mystery Oil is not an FAA approved oil for, it's not approved for oil or fuel. AvBlend and ChemGuard are. And somebody else said that Marvel Mystery Oil is an organic phosphate. So wear gloves. It's a neurotoxin. So be careful.
And that's very true. It's not approved. Um, and while ChemGuard and AvBlend and some of the others are FAA approved, they are not FAA certified. And there's a fine line between that. What the FAA has done is looked at those products and they have determined that they will not be harmful to the engine. But the FAA, to my knowledge, has not performed any gamut of testing or anything like that with regards to any of these additives to approve them or endorse them as certified for engines across the board. It is true that Marvel Mystery Oil is not an FAA approved or endorsed by the FAA in any way, and that's one of the reasons why I don't even, I just don't use it. Mm-hmm. I know, gosh, there's thousands of people that do and swear by it, but it's just not something that I've ever tested. And
yeah, understood.
Yeah.
Eric says, recommendation for turbocharged engine, straight weight or multi-viscosity?
You can use multi-weight oil in turbocharged engine. That's not a problem. It's depending upon the environment. And again, I'm going to go back to the whether it be a Continental or a Lycoming engine. Go to that the manufacturer as to what type of oil you should be using for the environment that you're in. If you're in a cold climate, a multi-weight oil is probably what you're going to choose. If you're in the South and you're never going to be in harsh cold conditions, a straight weight oil.
And this person says, I've got a goofy question. I found a gauze-like material in a screen-type oil filter. He thinks it's an insect nest. Possible? Any thoughts?
It certainly could be. I have certainly seen some weird things come out of engines and how they make them into the engine. I never know. Scotch-Brite, glass beads, things like that. Yeah, I guess it's not impossible that an insect could get in and build a nest within the engine somehow. But I'd probably investigate that a little further to make sure that it's not man-made. That it flakes apart. That it's not something that would be subject to stop up an oil feed to a connecting rod or something like that. Mm-hmm. But that's very interesting.
No name, but many oil change procedures that this individual has researched, draining or flushing the cooler and lines don't seem to get mentioned. Is there a recommendation or procedure for this?
That's a very good question. I'm not aware of any recommendation to flush the oil cooler or pressurize the engine to flush the engine of oil through the galleries and things like that. When we do an oil change, there is a lot of oil that's residual in the oil, in the galleries, inside the crankshaft, in little nooks and crannies. If you use a quick drain plug on the sump, there's quite a bit of oil that you're not getting out of the sump, because most of those items have a little standpipe, and when you twist it and push it, that's when it starts to drain. And that standpipe is higher than would be if you took it all the way out. Nothing wrong with a quick drain, but you have to understand that you're just not getting all of the oil out of the engine, nor are we in an automobile when we do an oil change as well.
Mm-hmm.
But that's the reason to warm the oil, is to try to get as much of that stuff out as you can.
Okay. With the comment, this isn't one of the questions, but I guess it's one of my questions. With a quick drain, understanding that there could be a little oil at the bottom of the pan and the heavier elements would sink to the bottom, should a quick drain be removed every second or third oil change to ensure that?
That's a very good point. And if in my particular, in our 182, we have quick drain on it, and I do that about once a year to pull that out, just to make sure that I get it, all the stuff out of there. I even go in there with my finger just to make sure that there's no sludge or anything like that in the bottom of the oil pan. The good news is that if those particles reside at the bottom of the pan, the oil suction pickup tube and screen is going to be elevated above that. So it's not like it's going to be the end of the world. For that stuff to just sit in the bottom of the pan is, not going to hurt anything. But once in a while I do that. It's not written anywhere. It's not in any manual. And I know I never go against the grain of manufacturer's recommendations, but I do that myself, just to ensure that I'm getting what I can out of the sump.
Okay. Catherine has a neat question. Where can I find a chemical description about how acids are created? Do you have one on your website somewhere? She's looked, but you can't find one.
No, that's a very good question, Catherine. We don't have any of that at the website. Shell and the oil companies, Exxon and the Phillips companies, publish documents. Shell has the answer book that was written by Paul Royko, and he talks about in that answer book a lot of the formation of these deposits. That's a very good resource. Shell and Phillips, Exxon and Phillips both have this similar resources. The Sacramento Sky Ranch Engineering Manual that was authored by John Schwanner and it's available online. He has a really good detailed section in there about the chemistry of what's happening in the engine under combustion and how that affects the oil and how the oil is designed to deal with that. So I would put those up for good reference for that.
Okay. Let's see here. Robert White. For an oil change, do you know of an engine that recommends letting the engine idle until oil return to oil tank, until the oil stops returning oil, to ensure all oil is drained?
No, I'm not aware of any procedure like that. I would think that could be very dangerous to starve the engine of oil. Again, if it's set forth, if the manufacturer says to do this procedure, I would do it. But I'm not aware of any procedure like that, and I don't think that I would try that at all. I
Okay.
think that could be very dangerous.
Okay. Thank you.
Mhm.
Terrence, can you switch back and forth between straight weight and multi-weight oil from summer to winter?
You certainly can. And again, in the answer book by Shell and those publications by the other by Phillips and Exxon talk about that. It's common for people to do that. It's actually with regards to Aeroshell, they're compatible with each other. So if you say you got straight weight in and you fly somewhere and they don't have any straight weight, all they have is multi-vis. As long as it's an Aeroshell project, a product, it's fully compatible. Same with Phillips, same with Exxon.
Okay, thank you. Well, again, for those that are Piper or Cessna, go to YouTube. You will have this conversation downloaded, and the previous webinars from Bill are already on the respective YouTube channels. And if anybody needs to get a hold of Bill, his website's available, his email. Let us know. We can put you in touch with Bill. The book, don't forget that, the 101 Management. And I think we're going to wrap it up for the evening and let Bill call it a night. But we do thank everybody. We had a ton of people here, but thank you very much. Thank you, Bill, Superior Aircraft Spruce, for sponsoring this. And to that, everybody have a great evening.
You too. Thank you.
Okay, thank you. Bye, guys.
Bye.